Hello everyone, today we're going to look at things that are called sinking funds and amortization. So basically we're going to be finishing off our table that we had before. We're going to be looking for these guys at the bottom. So these ones were from 19, these four are from 20. So solving for R knowing S and solving for R knowing A. So remember that S is the future amount. You can think of it as the amount before before interest, and A is that present amount, and we can think of that as the amount before interest. We're basically going to have two types of situations. Either you're saving money for some future event, or you're paying off money because you borrowed it. So if you're saving money, that is for S, and that is a sinking fund. So I'm saving up money to have some amount at the end. I know what I want at the end, so that's S, so that's what it's going to be. The amortization, you can even think of it as amortization A, is when you're paying off, say, a mortgage or a car loan. Okay, so if you're paying off money, that's A, that's amortization. If you're saving money, that's S, that's a sinking fund. The names don't really matter. You're not going to be tested on which one's called which. It's just knowing which one to use. So for our first example, Jake wants to save money for college. How much should he deposit every month into his bank, which pays 4.5% interest monthly, if he wants $20,000 after 4 years of high school? So how much should he deposit? That's a question of what is R. So that makes sense for this section. If you notice both of them, whether it's S or A, we're solving for R. So I'm looking for the repeated payment. What should he deposit every month? He's saving up money. He wants this $20,000 after the interest. I keep saying taxes. After the interest. So that's the future amount. That's S. Okay, so I know that I'm solving for R, knowing S. So that means I am in the top part of those four equations that we have left. And then it doesn't specify whether he wants to deposit it at the beginning of the month or the end of the month. And if it doesn't specify, we assume it's ordinary annuity. So of those the bottom half of that table, we're looking at the upper left one. Solving for R, knowing S for ordinary annuity. And then we plug in the numbers. So S is 20,000, and then we have our equation right here. Again, it's really, really important that you do this out on your calculator so you know how your calculator works. Okay? So I'm not going to spend too much time on that. I'm really just going to show you the equation, make sure you know which equation you're using, and then give you the answer. I want you to pause it though and do it out yourself. So if you do this correctly, you should be getting $381.07. So every month he has to deposit that. And at the end of his 4 years of high school, he'll have $20,000 at the end. Susan got a mortgage for her house for $225,000. What is her monthly payment if she has 5% interest monthly for 30 years? So she is paying off something that she borrowed. That is amortization. Again, amortization, mortgage, it comes from the same kind of root word there. This $225,000 is before the interest, so that's A, the present value. I have that there. So we know that she's solving for R. What's her monthly payment? What's her repeated payment? We know A. And then again, it doesn't specify if it's at the beginning or the end of the month, so we assume ordinary annuity. So of that 2 by 2, it is the bottom left. And if I plug in the numbers, it should look like this. Again, be really, really careful plugging it into your calculator. And you should be getting $1,207.85. Mike wants to make deposits at the start of every week into an account paying 3.25% interest weekly for 10 years so that he has $60,000 at the end. What must he deposit every week? So again, what must he deposit every week is R. He wants to have $60,000 at the end. That's the future amount. That's S. So again, I'm looking for R. I know S. He makes the deposits at the start of every week. That means it's annuity due. So I should be getting the equation for the top right of that 2 by 2. Again, solving for R, knowing S, annuity due. Plug all the numbers in. Remember, weekly, there are 52 weeks in a year. And you should be getting $97.63. For our last one, Carl took out a loan to make repairs on his house. He borrowed $70,000 for 10 years. If the interest is 6% monthly, what must he pay back at the start of every month? So he borrowed the $70,000. That is before any interest has been applied to it. So that makes the $70,000 A. What must he pay back at the start of every month? That's R. So again, we are looking for R. And it's the start of every month. That tells me it's annuity due. So that's the only equation we haven't used yet. Solving for R, knowing A, annuity due, the bottom right function formula. If we plug in all the numbers, it should look like this. Right. Monthly, there are 12 months in a year. Okay. Make sure you plug it in correctly, obey order of operations, and you should be getting $773.28. Right. So again, it's really important that you're using the correct equation and then make sure you plug it in correctly. But most of what I'm looking for is, are you using the correct equation? Okay. So make sure you read the book, try out the problems, and let me know if you have any questions. Thanks.